What we're going to take a look at today is simplifying using some of the square root properties that we've been going over, which I have written up on the top. The first one says if we have square root and we're multiplying two things underneath that square root, we could split them as such. So if I had 4 times 16 underneath here, I could split it as the square root of 4 times the square root of 16. Same thing over here. If I have the square root of some fraction, I can really take the square root of the numerator and divide it by the square root of the denominator. And that's going to help me go through and kind of reduce radicals. So our first one, if I take a look at this, the square root of 48. If I go through and I want to reduce that, what I need to look for is some square number that is a factor of 48. So what would help me is if I had all of these numbers written down on the side and it could continue onward and onward. Just knowing the square numbers is really going to help. So what I need to think about is which of these numbers is a factor of 48. So looking at this, I say 1, well that's obviously a factor of it, but that's not going to help me simplify. If I look at 4, 4 does go into 28. So what I could really do is I could write this as square root of 4 times the square root of 12, because I know that this is true. 48 can be rewritten as 4 times 12, so I just split these and I say the square root of 4 times the square root of 12. I know what the square root of 4 is. That's 2. What I'm left over with is the square root of 12. And I can continue the process here. I can look at this and say, alright, well I could continue to break down that 12 into square root of 4 times 3, and which can be broken down as such. 2 times the square root of 4 times the square root of 3, which we reduce to 2 times 2 times the square root of 3. And I could just multiply the 2's together, which would end up giving me 4 times the square root of 3. Now what I could have also seen for that 48 is that if I continue to go down, 16 is also a factor of 48. So I really could have broken this down into 16 times the square root of 3, because 16 times 3 equals 48. And then really from there, I get the same exact answer, 4 times the square root of 3, no matter how I go about doing that. And really, my process would be the same for the square root of 45. I would go through and say, 1, I'm going to skip over, 4 is not a factor of this, but 9 is. And I can rewrite that as the square root of 9 times the square root of 5. And I can reduce that square root of 9 to 3. Now looking at this, there's nothing else I can do to that square root of 5. So that would be my final answer for the square root of 45. This would be that in simplest form, and 4 times the square root of 3 would be square root of 48 in its simplest form. Now our process will be a little bit different when we look at these ones, because we're going to have to use the quotient property now. And what that tells us, as we have up here, if I have the square root of a fraction, I could take the square root of the numerator and divide that by the square root of the denominator, which I'm going to go through right here. To simplify this, what our rule tells us is I could take the square root of the top in the numerator and divide it by the square root of the denominator. So looking at this, square root of 16 I can reduce to 4, square root of 25 I can reduce to 5. So what that tells me is the square root of 16 over 25 is really equal to 4/5. And it's nice when both the numerator and the denominator do simplify and they are perfect squares, which is not going to happen over here. Because if I look at this and I want to simplify this because I don't like the fraction inside of the square root. That's one of the things that we mentioned in class that we want to get rid of. We don't like the fact that we have a fraction inside a square root. So I'm going to go through the same process. I will break this up into the square root of 5 divided by the square root of 2. Now looking at those, there's nothing that I can simplify here. You know, I can't use my rule from above. I can't actually just take the square root of 2 or the square root of 5, because those are not going to be simplified. So what I have to go through and do is the technique from class that we called rationalizing the denominator. Because if I look at this, what I also don't like is the radical sign in the denominator. I want to get rid of that. And what we had done in class to do that is we multiplied by the square root of 2 over square root of 2. Whatever we have in the denominator underneath the radical sign, we multiply both the top and the bottom by that. Because what that's going to end up doing is it's going to get rid of the square root sign. Because if I take a look at this, kind of using the rule from above, if I'm multiplying two numbers underneath the square root sign, I can combine them and just multiply their contents. So if I look at this, what that rule is telling me that I can do is multiply together 5 and 2, and I can also multiply together 2 and 2 down here. So what that says is I have the square root of 10 over the square root of 4. Looking at these, square root of 10 I can't simplify anymore, but square root of 4 I can. I can reduce that to square root of 10 divided by 2. And looking at that, we remove the radical out of the denominator, so this is actually in its simplest form now. Instead of having this up here where we had a fraction inside and then we ultimately had a radical in the denominator, we got rid of that by going through and using our properties.